how to calculate electric flux due to a dipole, right? So I have taken here an electric dipole, a system of two equal and opposite charges. This is plus Q and this is minus Q. Now I have to find what is the electric flux through a disc or a ring in the equatorial plane of the electric dipole. Suppose the radius of the ring or the disc is R and each charge is at a distance of R from the disc on either side of the disc. Now, we know the electric field in the equatorial plane is opposite to the dipole moment of the electric dipole. So, dipole moment is anti-parallel to the electric field. The electric field is from the positive charge to the negative charge, that is perpendicular to the disc here. Now, how to calculate the electric flux through this disc? First of all, I will see what is the solid angle subtended by each charge at the periphery of the disc. Now, if alpha is the semi-vertex angle subtended by the periphery of the disc at one of the charges, then the solid angle subtended is given by omega is equal to 2 pi times 1 minus cos of alpha, where alpha is the semi-vertex angle. Now, the flux due to the dipole is the flux due to the positive charge and the negative charge. So, flux due to the dipole is equal to phi plus Q plus phi minus Q, right? Now, the general formula for the flux is Q divided by epsilon naught. So, it is omega divided by 4 pi. So, this is omega divided by 4 pi. Then due to the negative charge, it will be again Q divided by epsilon naught. It is omega divided by 4 pi. Now, why I have taken here plus sign? Because the electric flux or electric field lines are from the positive charge towards the negative charge. That is, through the disc, it is in the direction of left to right. Okay, so when I add these two, so what I get, it is 2Q divided by epsilon naught, right? So then it is 2 pi, then it is 1 minus cos of alpha divided by 4 pi. So phi d is equal, it is Q divided by epsilon naught, then it is 1 minus cos of alpha. Now cos of alpha is, this is base divided by hypotenuse, so it is R divided by under root of, it is R square plus it is R square, right? Now here the question arises, what is the flux through the whole equatorial plane? So for whole equatorial plane, I have to extend the disc to infinity. That means the size of the disc should be infinity. That is only possible when this R tends to infinity. So I have to take here R tends to infinity, right? So when R tends to infinity, so this will be R divided by, this is infinity. So anything divided by infinity is 0. So what I get here, it is Q divided by epsilon naught times 1. So that is Q divided by epsilon naught. So this is the flux due to the electric dipole through a ring or a disc in the equatorial plane, right? Now, if instead of the dipole we have two charges here, it is Q1 and Q2, both are like charges, that is either positive or negative, right? So if we take here the positive charge, then what we have to do here, the total flux is phi Q1 minus phi Q2, because the electric field lines from this charge will be towards this side, electric field lines from this charge will be towards this side. So the field lines are opposite to each other. That is why we take here phi Q1 minus phi Q2. So if the distance of the charge from the center of the ring is say x1 and x2 for Q1 and Q2, then we can calculate here the flux as it is Q1 divided by epsilon naught, it is omega 1 divided by 4 pi, where omega 1 is the solid angle subtended by the disk at Q1 and omega 2 is the solid angle subtended by the disk at Q2. So we can calculate it as it is Q1 divided by it is 4 pi. So then it is epsilon 1 minus it is x1 where this is cos of alpha 1. So this is cos of alpha 1. So it is x1 divided by under root of x1 square plus r square. Then minus it is Q2 divided by 4 pi epsilon naught 1 minus x2 divided by under root of x square plus r square. So this is the flux due to the system of two charges on the axes of a disk or ring at distances x1 and x2. But now the question is, do we have always the disk at the equatorial plane or in the equatorial plane? No, we can have a rectangular plane also. Now if we have a rectangular plane like this, A, B, C, D, whose length is L and whose breadth is B. So this is length L and this is breadth B, and then at a distance of H from the center of the rectangular plane we have a positive charge here plus Q, and at a distance of H from the center of the equatorial plane we have a charge minus Q. That means again a system of two equal and opposite charges. Now in this case what we have to do, again we will use the general concept of solid angle. So what is the solid angle subtended by this rectangular plane at charge plus Q or at charge minus Q, which is at a distance of H from the center of the rectangular plane on its axis. So that is given by omega is equal to 4 sine inverse. It is LB, where L and B are the dimensions of the rectangular plane. It is divided by square root of L square plus 4H square. Then it is B square plus 4H square. Now, therefore, electric flux through the equatorial plane ABCD, that is phi ABCD is equal, since we have two charges as we did it here, so it is 2 times it is Q divided by epsilon naught, it is omega divided by 4 pi, right? So I can write here it is 2Q divided by epsilon naught, then it is 4, it is sine inverse LB divided by under root of L square plus 4H square, then it is B square plus 4H square divided by 4 pi. This 4 and 4 will cancel, so we can write it is 2Q divided by epsilon naught, it is sine inverse, it is LB divided by under root of L square plus 4H square, then it is B square plus 4H square. Now, here, if the rectangular plane is converted into the square plane, so then what we can do here that it is L is equal to B is equal to A, say, so you can calculate what is the electric flux through the square plane, right? Now, again, if L is equal to B is equal to A is equal to H also means if the half length of the dipole, that is from the center of the dipole to either charge, is equal to the dimensions of the square, then we have L is equal to B is equal to H is equal to A. So we can calculate then what is the flux through the square plane at a distance of A, that is equal to the dimensions of the square. So then we can get here it is phi, it is ABCD is equal, it is 2Q divided by, it is pi epsilon naught. So when we give here the values, we get sine inverse, so it will be equal 1 by 5. So this will be the flux through the square plane when the charge is at a distance of A from the center of the square plane whose dimensions are also equal to A. So this is how we calculate the electric flux due to a dipole through a ring.